So we're going to continue with conic sections. I do want to do one more example, and then we're going to go on to eccentricity. So this example says, show that the equation x squared minus 4y squared plus 2x plus 8y minus 7 equals 0 represents a hyperbola. Then it asks you to find its center, asymptotes, and foci. Okay, so if we remember from before, a hyperbola looks like x minus h squared over a squared plus y minus k squared, no, minus y minus, I wrote it right, I said it wrong, over b squared is equal to 1. So we need to get it into this standard form. And then after we get it into the standard form, then what we want to do is we can find the asymptotes. We can also find, we can find the foci, the center, and asymptotes. Okay, so we're going to do some completing the square. So I'm going to start off with x squared plus 2x. And then I have minus 4y squared plus 8y. And I'm going to add the 7 to both sides. Okay, so now I have x squared plus 2x. So if I complete the square on that piece, that means I'm going to add 1. And then I'm going to factor out a 4. And that's going to give me y squared minus 2y. And so therefore, I'm going to again add a 1. And that equals 7. Now, from this piece, I added 1. So I need to add the 1 from that one piece. And from this piece, as you can see, I have negative 4 times 1. So therefore, I actually subtracted off 4. So I need to add it back on. This is negative 4. Why is this wrong? X squared minus 2y, y squared minus 2y plus 7. And then x squared, and I have minus 4y. Oh, I essentially subtracted off 4. You see, I've subtracted off 4. So I need to subtract off 4 on the other side. Okay, now it's right. Okay, so now I end up with this piece is x plus 1 squared minus 4 times y minus 1 squared. And that is going to equal on the right-hand side 4. So then I'm going to end up with x plus 1 squared over 4, because I'm dividing both sides by 4, minus y minus 1 squared is equal to 1. So now it is in standard form. And in the standard form, I can see that this is x minus a negative 1 and y minus 1. So this is my center. Okay. I can now see that a squared is 4 and b squared is 1 and c squared is a squared plus b squared. So that's 5. So that lets me know that c is equal to the square root of 5. All right, so now why did I find c? What's the big deal with c? You remember? What's the importance of c? Naya, are you there?
Yeah, I'm still here. I'm sorry, I was just looking at it. Is that the Pythagorean theorem?
Well, no, c is the part that goes into the focus.
Okay.
Okay. So now remember when we had, let's say, x tilde squared over a squared plus y tilde squared over b squared, and I want this to be a negative, is equal to 1. This center is negative 1, 1. And no, this center is 0, 0. And if I make this the 4 and that the 1, then the c in this problem is the square root of 5, just like the c in our problem. But this one has center 0, 0. The one that we're looking at has been shifted. So this one, let's say number 2, is the original one that's not shifted. Our problem is shifted. Number 1 is our problem. It's shifted. So the center, which was 0, 0. So for this one, the center was 0, 0. Our center is now negative 1, 1. So our center is now here. So that means that not only does our center move, but our foci move and our asymptotes move. Okay. So to find the asymptotes, well, let's go ahead and find the foci. Okay, so the foci of this problem would be at plus or minus 5, 1. So the foci for this problem would be at plus or minus the square root of 5, 1, which means then that the foci from our problem are shifted. So they are minus 1 plus or minus the square root of 5, 1. So they shift. And this one is actually a 0. This one should be 0. Okay. And then when we go to find our asymptotes, We find the asymptotes by solving x plus 1 over 2 is equal to plus or minus y minus 1. Actually, I like it the other way around. Plus or minus x minus 1, x plus 1 over 2. So therefore, that's what our asymptotes are. So y is equal to plus or minus x plus 1 over 2 plus 1, and these are the asymptotes. Okay, so now if I wanted to graph this thing, let's think about this. It's actually not that difficult. So the original, so now we know that our center is minus 1, 1. So I'm just going to take this, cut that. Well, how weird is that? It didn't move the dot. Interesting. Okay, so minus 1, 1 would be here. I'm going to I'd like to lengthen this. Okay, this is gonna get on my nerves, so we're gonna draw it all over again. Okay. So there's minus 1, 1. That's our center. Okay. So now the slope of our line is to go up 1 and over 2 and down 1 and over 2. So if we go, the slope is, the rise is 1. And then we're going to go 2. So this is going to be 1 asymptote. Not too bad. And the other one is up 1 and over 2. Okay, so here's our other asymptote. So from our center, we go over 2, 1, 2 right here. And this way we go 2 and we draw our box. It's a little off. And then, oh, I want that red. Okay, and there's our purple. Okay. All right, so let's talk about eccentricity. So what does that mean? Well, you know, some hyperbolas and some ellipses are kind of flat. All right, so the eccentricity talks about the ratio of the different axes and what we have. Okay, so eccentricity. All right, so so we want to determine the center of focus distance C for an ellipse. Okay, so let's talk about an ellipse. So we want to determine the center of focus C for an ellipse. Now we already know what that is. So for an ellipse, remember we had x squared over a squared plus y squared over b squared is equal to 1. And C is the square root of a squared minus b squared. And of course, remember for a hyperbola, it's a squared plus b squared. Okay, and a squared in this is our major axis. So the a goes along the major axis. It's the larger number. So we want to fix a. And we want to vary c over an interval. Zero less than or equal to c less than or equal to a. Okay, and it results in an ellipse of varying shape. All right, so if a is equal to b, then c will be 0. And if a is equal to b, then you end up with x squared over a squared plus y squared over a squared is 1, or x squared plus y squared is equal to a squared. And oh my, that is a circle. So the ellipse begins to flatten as c increases. All right. If c is equal to a, then that means that b is 0. And then the foci and the vertices overlap and the ellipse becomes a line segment. Okay, so what does that look like? Okay, so remember A is the larger axis. So let's say that here A is 3, and C is 2, B is 2. So we're going to let A equal 3 and B equal 2. So we end up with this ellipse. Whoops. Okay, so that's my ellipse. All right, A is C and B is 2. My B does not look very good here. I didn't go down far enough. It should actually. 1, 2, it should actually be down that way. Okay, that's much better. Okay, so now what in our case, C is going to be A squared minus the square root of A squared minus B squared. So C is the square root of 9 minus 4, which is the square root of 5. Somewhere around 2.3, I think-ish. So C is somewhere here. Now, as we let C, as A becomes C, this thing actually becomes a circle. Okay, so if A and B become the same number, let's say 2, so here's A and B now equaling 2, C is 0, and we just get a circle. But if A is equal to B, if C becomes equal to A, then it stretches out, and so this has to go in. So the further this goes out, the more this has to come in, and you end up with a line segment. Okay, so that's what I was talking about. So that makes a difference what C is in relationship to A and B. So the eccentricity, this is what helps us determine how flat or how round it is. So the eccentricity of an ellipse all right, for an ellipse where A is greater than B is E, and E is defined to be C over A. So this is the square root of A squared minus B squared over A. So that's the eccentricity. So we can talk about different eccentricity, in particular, like planets. So here's an example. Planets revolve around the sun in an elliptical orbit. Okay. So here's the sun. Can you see that yellow dot? I think so. All right. And so Venus and Earth have eccentricities that are very close to 0. All right. So not quite a perfect circle, but pretty close. Okay, so Venus has an eccentricity of 0.01, almost a perfect circle, because A is almost equal to B. And then the Earth, its eccentricity is 0.02. Again, A is very close to B. But Icarus, which is a planet, has eccentricity equal to 0.83. So it travels more like this. Okay, so it travels more like that. All right. So that's how you find the eccentricity of an ellipse. So a parabola has one focus and one directrix. An ellipse has two foci and two directrices. Okay, these are the lines perpendicular to the major axis perpendicular to the major axis at distances plus or minus A over E from the center. Okay. So we talked about the foci of the parabola. So if you remember, let's go back just for a brief moment. So when we had the parabola, and we drew our parabola as such. And then this was our focus. And then our directrix was down here. So this was 0p. And this was the line y is equal to negative p. And this was y is equal to x squared over 4p. Okay, so that was when we talked about the parabola. All right. So and we said that any point on the parabola right here, remember this was the focus and this is some point P, and this was the point Q, I think I called it. And we said that for the parabola, the distance from F to P was the same as the distance from P to D, P to Q. Okay, so we talked about that. So this distance right here was the same as this distance right there. Okay, so with an ellipse, it's just a little bit different. So for an ellipse, we have something that looks like this. Okay. So we went out and we had this, these are our vertices and our foci were like this. And then we had the minor axis like this. I mean, 1, 2, 3, 4, 5. 1, 2, 3, 4. I feel like it's here. Okay. And then here was our ellipse. Oh, that's why that looks crazy. It's not supposed to go through there. It's supposed to go to the other point. Much better. Okay, it wasn't looking like an ellipse to me. Okay, so now there's my ellipse. If you remember, up here was B. This was minus B. This was A. This was negative A. Okay, and then any 2 points, we kept the distance, the sum from here to here. And then we took that point and did that. And so for the ellipse, we kept this distance was constant. Okay, and this was some point on the curve. So here's P. And we said the distance from, this is F1 and F2. And we said the distance from F1 to P plus the distance from F2 to P is equal to 2A. And that's how we derived it. Okay. Well, the directrix is here. That looks pretty good. Okay, so this is directrix 1. And this is directrix 2. And the way that you find them is this one is x is equal to minus a over e. And this one is x is equal to positive a over e. So those are the directrices. And it is true that if you take the distance between P and F1, that's going to equal the eccentricity times the distance of P to D1. And the distance from P to F2 is going to equal the eccentricity from P to D2. Okay. So the directrix x equal to minus a over e, and you can find that corresponds to the foci negative c 0, and the one that's x equal to positive a over e corresponds to f2 being positive c and 0. Okay, so that takes care of that. And then the hyperbola, well, its eccentricity, well, what is c? C is the square root of a squared plus b squared over a. Okay, again, c over a. All right, so let's locate, here's an example. Locate the vertices of an ellipse of eccentricity (0.8). So E is equal to 0.8. Okay, so this ellipse is kind of flat. whose foci lie at points zero plus or minus 7. Okay, so just looking at that, can you tell me what's the major and minor axis of this ellipse? Anaya, are you there?
Yeah, I'm still here. I'm sorry. I said the Wi-Fi is really bad here, so I can't really like hear you. Sometimes it'll cut in and out.
Okay, all right. So if you remember when we talked about an ellipse, the foci are on the major axis. Okay, so for this problem, the foci are at 0 plus or minus 7. So therefore, we can clearly see that the major axis is the y-axis. Okay, so that's the first thing that we know. And so if those are the foci, then C, we also know that the vertices are at, so those are the foci, that means C is equal to 7. Okay. And the vertices are going to be here and here, which is going to be A, 0A, and 0 minus A. So the vertices are at 0 plus or minus A. Okay, so the eccentricity is C over A. And we know that that is 0.8. So therefore A is going to be C divided by 0.8, which is 7 divided by 0.8. And that turns out to be plus or minus, well, it turns out to be 8.75. So now my vertices are at 0 plus or minus 8.75. And actually, we can even find B. Okay, because with a ellipse, you can find B. Because with the ellipse, A squared minus C squared is B squared. Okay, so B is the square root of A squared, which is 8.75 squared, minus 7 squared. So if I compute that, I get the square root of 8.75 squared minus 49. So that's 5.25. So therefore, I know B is somewhere like here and here. So this is 5.25, 0, and this is negative 5.25, 0. And I already know what A and B are. So therefore, I can actually draw an ellipse just by me giving you the eccentricity and the foci. You can draw the ellipse. Okay. And example 2 is find the eccentricity of the hyperbola nine x squared minus 16y squared is equal to 144. Okay, so we need to change this. So we get 9x squared divided by 144 minus 16y squared divided by 144 is equal to 1. So that gives me x squared over 16 minus y squared over 9 is 1. So again, that's easy to graph. Okay, so to graph that, it's very easy. My center is 0, 0. So now I need to go in the x direction 4, 1, 2, 3, 4, and in the y x direction 1, 2, 3, 4, in the y direction 3, 1, 2, 3, in the y direction 1, 2, 3. I can draw a box just like this. And as I draw my box, just like this, I can then draw my asymptotes, which very nicely come through here, like that. Hey, that's not too bad, almost perfect. And then this one goes through here. Wow, that's pretty good, Dawn. All right, and so therefore our hyperbola looks like this. Okay, but that's not what we were asked to do. We were asked to find the eccentricity. Okay, we have 2 minutes. So a squared is 16. That's this value right here. And then we know that b squared is 9. All right, so I'll color it yellow. All right, so how do you find c for the hyperbola? So for the hyperbola, c squared is equal to a squared plus b squared. So that turns out to be, I have 1 minute. That turns out to be 25. No, it doesn't. Yes, it does. So therefore C is 5. So the eccentricity is C over A, just 5 over 4. Okay. The last thing is for a parabola. the eccentricity is equal to 1. Okay. All righty, so let's see. I'm going to stop. No, I'm going to stop the recording first. Okay.